Engineering projects are not just about technical marvels, they are also about financial viability. Understanding the language of money, cash flow, and interest rates is crucial for engineers. Cash flow represents the inflow and outflow of money during a project's life. Positive cash flow means more money is coming in than going out, a desirable situation. Interest rates, on the other hand, represent the cost of borrowing money or the return on investment. Higher interest rates mean higher borrowing costs, impacting project feasibility. Engineers must carefully analyze both cash flow and interest rates to make sound financial decisions. Understanding these financial fundamentals is key to successful project implementation. For example, consider a renewable energy project. The initial investment in solar panels or wind turbines is significant. However, once operational, these projects generate revenue through electricity sales. Engineers must accurately estimate both the initial costs and future revenues, factoring in interest rates and inflation, to determine the project's long-term profitability and attract investors. Cash flow in engineering projects can be categorized into recurring and non-recurring flows. Recurring cash flows, as the name suggests, happen regularly throughout the project's life. These include operating and maintenance costs such as labor, materials, and routine repairs. Recurring cash flows are like the heartbeat of a project, essential for its continuous operation. Non-recurring cash flows, in contrast, are one-time events. These typically occur at the beginning or end of a project's life. For instance, the initial investment cost of purchasing equipment or the salvage value at the end of the project's life are non-recurring cash flows. Understanding the timing and magnitude of both recurring and non-recurring cash flows is crucial for effective project budgeting and financial forecasting. Take the example of building a bridge. The initial construction cost, including materials and labor, is a significant non-recurring cash flow. However, once operational, the bridge will incur recurring costs such as maintenance, toll booth operation, and periodic repairs. Accurately forecasting and accounting for both types of cash flows is critical for determining the bridge's long-term financial sustainability. Cash flow diagrams are visual representations of a project's financial timeline. They depict the inflows and outflows of cash over time, offering a clear picture of the project's financial health. These diagrams use arrows to represent cash flows, upward arrows for inflows, revenues, and downward arrows for outflows, expenses. The horizontal axis represents time, typically in years, while the vertical axis denotes the magnitude of the cash flow. Cash flow diagrams simplify complex financial information, making it easier to visualize the timing and magnitude of cash flows, aiding in decision-making. For instance, when evaluating the feasibility of a new manufacturing plant, a cash flow diagram would illustrate the initial investment cost, followed by operating expenses and projected revenues over the plant's lifespan. This visual representation helps stakeholders understand when capital is required and when returns can be expected, facilitating informed investment decisions. The time value of money is a fundamental concept in engineering economics. It recognizes that money available today is worth more than the same amount in the future. This is due to the earning potential of money through investments. Money invested today can earn interest, leading to a larger sum in the future. This concept is crucial for comparing investment alternatives and making informed decisions about project funding and resource allocation. Discounting is the process of calculating the present value of future cash flows, considering the time value of money. By discounting future cash flows to their present value, engineers can compare projects with different lifespans and cash flow patterns on a level playing field. For example, when choosing between upgrading existing equipment or investing in new technology, engineers must consider not only the upfront costs but also the long-term operational savings and potential revenue increases. Discounting these future cash flows to their present value allows for a more accurate comparison of the two options, leading to a financially sound decision.